Hello everybody, this is Mr. Donaldson, and today's video is going to talk about reflection. This is a part of a series about transformations. Let's look at the four types of transformations. You have a translation, which is to slide an object, a reflection, which is to flip an object, a rotation, which is to turn an object, and a dilation, which is to make an object larger or smaller. Here are our vocabulary terms for this lesson. We have a transformation, which is the mapping or movement of all the points of a figure in a plane according to a common operation. A reflection is a transformation that flips a figure over a line of reflection. A reflection line. This is a line that is perpendicular bisector of the segment with endpoints at a pre-image point and the image of that point after reflection. And finally, congruent figures. These are figures that have the same size and shape. Today's lesson is about reflections. As mentioned before, a reflection is the flipping of an object over a line. This line may be called the line of reflection or reflection line. Another way you might be familiar with a reflection is when you look in the mirror. Here are some examples below. In the first image, the line of reflection would be right there across the middle. In the second image, the line of reflection is the red line going diagonally. And then the final one, the line of reflection in this case would be the x-axis. That's the line that the first shape is flipped over to make the second shape, which is congruent. Here's how it works. If you reflect a shape across the x-axis, which is right here, you're going to change the y value of each point. You turn a positive to a negative or a negative to a positive. For example, if a point is 3, 4, if you reflect over the x-axis, it becomes 3, negative 4. On the other side, if you reflect across the y-axis, which is right there, you change the x value. Turn positive to negative and negative to positive. For example, if we're reflecting the point 3, 4 across the y-axis, it becomes negative 3, 4. If you flip across the x, change the y. If you flip across the y, change the x. Here are some examples. In the first one, we're going to reflect across the x-axis. Remember, if you flip across the x, change the y. So our first point would be A. And remember, we mentioned in the first video, when you reflect, it becomes A prime. And we're going to change negative 1 to positive 1. The B value would become B prime, which would be 4. Change the Y value, which would be negative 2. And the C value would be C prime, and that would be 4, positive 4. In the next example, we're going to reflect across the y-axis, so if you flip across the y, change the x. So it becomes x prime, and that would be negative 3, 4. Y prime would be positive 2, 3. And z prime would be, well, what's the opposite of 0? Well, that's just 0. So it would be 0, negative 1. So, flip across the x, change the y, that we did here. Flip across the y, change the x, that we did here. When reflected on a graph, you can do things a little differently. What you're going to do is find the line of reflection for each problem and count the spaces each point is away from that line. Here's how it works. Number 1 wants a reflection across the x-axis. So let's locate our line of reflection, which is here, the x-axis. And now we count how far each point is away from that. We'll start with Q. Q is there, and it's one space below. I'm going to do the opposite and go one space above. So Q's new point would be there, and I'll label it Q prime. I now repeat that process for each point. Start with G now. G is there. It's 1, 2, 3, 4 above. So we go 1, 2, 3, 4 below. Put a dot. Label it G prime. Now on to L. 1, 2 above. 1, 2 below. Put a dot. Label. Do you remember what the last thing to do is? Connect the dots, just like you did when you were little. So we now have reflected the first triangle across the x-axis. Number 2 may seem a little tricky, where it's not asking us about the x-axis or the y-axis, it's asking us a reflection across y equals 3. So you've got to locate where does y equal 3. The first thing you want to do is locate the y-axis. Hopefully you know it's right there. Now where does y equal 3 on that line? Start at the origin. 1, 2, 3. That's where y equals 3. So that line is our line of reflection. Now we do exactly what we did in the last one. Start with point L. L is 1, 2 below, so I go 1, 2 above. And it looks like it's going to match up with where U is right now. Let's look at U. It's 1, 2 above, so I'm going to go 1, 2 below. Put my dot. Label it U prime. And finally, let's look at X. X is 1, 2 above, so I go 1, 2 below. Put a dot. That becomes X prime. What's left to do? Connect the dots. And I have now reflected the first triangle over the line y equals 3. The final thing you need to be able to do with reflections is to be able to describe what reflection occurred on the graph. Let's look at the example on the left. We have the shape on the right is the original shape, and it was reflected to make the blue shape. To do this, you need to find the middle line. You can simply look at a point, let's look at point G, and try to find the line that comes in between there. Based on what I see, I think this is the line that comes in between the 2 points. Let's see. It's 1, 2 away there, 1, 2 away there. Just to make sure, let's look at all the other points. X is 1, 2, 3. X prime is 1, 2, 3. F is 1, 2, 3, 4. F prime is 1, 2, 3, 4. So that would mean that this right here is my line of reflection, or the reflection line. So if I wanted to describe it, I would say that it was reflected, and what is that line? Over the y-axis. Okay, the second one, the example on the right, I need to find the line that's in the middle of those two. Hopefully you won't see it's too difficult. It's this line here. Well, I know it's not the y or the x-axis, so what is it? Find the point of that line of reflection that crosses an axis. Okay? It's right there. So what axis is this? It's x. Alright? And what number is that? If I start at the origin, I go left 2, which means negative 2. That means this was reflected over a line x equals negative 2. And that's all there is to describing a reflection that is on a graph. This concludes our lesson on reflections. Hopefully you know a little bit more about it now. If you have any questions, feel free to contact me at either my email, robert.donaldson@hallco.org, or on Twitter at Mr_Donaldson. Until next time, thank you.